Alright, and here we are in week 12. So we're dealing with the manipulators now. So we started at the source of the electron flow, okay, up on the ship or the rig. And now we're going right to the fingertips of the ROV. Alright, so follow along in your lessons, and hopefully it made sense, the 12 weeks of slides. I can't see it hasn't, but anyway, question me if you need to. So here we are, remotely operated manipulators. 4, 5, and 7 function solenoid controlled SC manipulators are standard equipment on most world-class ROV systems. The industry leader Schilling Robotics introduced its first hydraulic-powered underwater remotely controlled manipulator in 1986. Schilling manipulator systems are used on more than 90% of all ROV systems in use throughout the world today. Now there are other manufacturers, okay, so I'll give you some info on that later. They are currently utilized for ROVs in support of the offshore oil industry, offshore mining, telecommunications, scientific, nuclear, and military operations. All hydraulic and electrical controls are protected as they are routed internally through the arms. So there are two basic types of manipulator arms: rate controlled and position controlled or spatially coordinated. Basic rate controlled arms are operated by simple on-off or bang-bang rate control solenoids, which we talked about, and are good for most subsea work that requires strength but not fine motor movement ability. Remember now what I said about the grabber and the T4, right? The fiddle player. Position controlled arms are servo controlled, provide fine motor control and dexterity, and are much smoother to operate, but are typically not as strong as rate arms. Okay. So once again, the rate controlled arms, these arms are typically very robust and strong, with the Atlas arm, for example, able to perform full reach lifts up to 250 kilograms, 550 pounds, with maximum lifts of 500 kilograms. Right, so that's when it's in closer. Just like you lifting, you can lift something closer to your body, okay? So the arm works that same way, right? It's a lever thing. Alright, physics. 1100 pounds. On-off function of the linear and rotary actuators can be abrupt due to the nature of the rate control valve. The subsea rate arm system usually weighs less than position controlled arm systems, as it shares the ROV's hydraulic system. It does not require an electronic slave battle to control the hydraulic functions. Examples are Rigmaster, Atlas, Conan 7 functions, and Orion arms. So rate control arms utilized as standard Schilling's robotics rate hand controller picture below. This ambidextrous unit is affectionately called a bear claw. Simple operation. Digital surface interface available as a dual belly packet controller for multiple arm operation. Alright, so like you can use this on a 7 function too, right? Or 5 function. Now you could wire it to whatever you want it to, but this one here, you press on this button, you haul back on the bear paw, shoulder up, press in on that button, push forward on the bear paw, going this way, shoulder down. Alright, the extension, pressing on the button, haul up, you can retract in, press in, push forward, extend out. Okay, should be farthest, so this is on either side, right? This one is on this side and this one's on that side. They do the same function usually. This would be like jaws closed, that would be jaws open. Does that make sense to people? This being the palm, this being the fingers. The furthest one out is the fingers, okay? You could yaw, starboard, and port with these two, if you had that function. If you just pull this left or right, you would make the arm rotate, like lateral, okay, left or right. And this would be pitch if you had a pitch function. And a 7th joint. So once, and that depends of 50-50 if pushing in is up and hauling back is up, or down on it. It's just the way people wire it, and I guess it depends on your supervisor. Clear as mud, I'm sure. Anyway, you'll be practicing lots of it on the simulations, okay? So we do have this on the simulators, okay? So here's a valve function rig master. Has no electrical subsea connections. So these are hydraulic lines, okay? Big and Dumb is designed to grasp and lift heavy objects and anchor RV to subsea structures. Constructed primarily with titanium for lightweight and strength, it is the highest lift to weight ratio in its class. Alright, so something to know now. The torque values are, important. Refer to the maintenance manual. Do half torques, okay, on them. Titanium becomes brittle. The Sikorsky helicopter, the Cougar helicopter that crashed, right, was a titanium screw or bolt that sheared off. Okay, so titanium, and I've seen them, once these break off, they can easily get out with your fingernail, or it could be a nightmare, like a day's work, right, where oversaws and holes and all that, tapping and re-drilling, and they can be a nightmare, okay? Or they can be, like I said, you can get it out with your finger. So do half torques first. Meaning if it's 30 pounds, go to 15 and then work your way up. So UK based Whittaker engineering manufacturers the M5 arm, which is another popular 5-function macro manipulator designed for heavy lifting and holding. This model incorporates internal high pressure water piping to facilitate jetting tasks without the risk of damaging the conduit. So in the old days, like this, if you want to hook up a jetter to it, you would have to externally route a hose, okay? You can see the problems where this can extend out and retract in. So you got to become an artist. You got to be able to route hosing and, on the old arms, and lights with an electrical cable if it's not internally built on the certain arms. Loose enough to move with the arm, tight enough that it don't get caught. Be used as a snag. Remember the term snags, or get sucked in your thrusters. Alright, so this ain't very clear, but this is, this is what I was saying, the second button. You push in and go forward on the bear paw. Out comes the forearm, okay? Now I can't really make it out there, but we'll just go to here. Alright, reach. Got it there, I'll just give it to you. Subsea FMC Technologies now owns Schilling Robotics. Okay, so if you go to Schilling Robotics, FMC might show up first, okay? So you got to look a bit. So here it is, reach, extended out 1372 millimeters, okay? Here's all your clear as mud once again. So here's your rate controlled. Again, the 7 functions, titanium construction, can lift. This is the Conan now, because it's supposedly built like a bodybuilder's arm. That's what they call it. The Conan arm is the most prevalent arm in the industry at this time, prone to breakage with rough use. So these could get sheared off a lot. I heard tell of a fella once ripping all this section off the whole claw, okay? Spare parts are expensive. Very expensive. Here's the Atlas. So it's a bigger version of the Conan. Conan was a man and Atlas was a titan. I guess that's the reasoning they're saying. None of it ever existed, but anyway. Can lift 500, 1100 pounds or 250 at the full reach. 500 kilograms or 250 kilograms, okay? Based on the ubiquitous Conan arm is light and very strong. So these are the type of jaws you'd have, right? So you should be able to do, in less than 10 minutes. Probably 4 minutes if you had the right wrenches with you to change these out. Once you do it several times, it becomes easy. It's a bit tricky at first, but you just got to do it. And remember, so it's no good doing it once and then 7 or 8 months later doing it again, okay? Like he wants to do this on your first hitch, every day, every second day, which is more than 3 or 4 times. And you should have it down pat. So that's basically the setup. Okay, once again, notice that the camera covers are on the cameras and is pointed down, okay? You don't want the sunlight, this pointed up with sunlight without no covers. It harms the camera. Alright, so this is what I'm talking about. This hose is externally mounted on, okay? See that there? There's a T4. The T4 is a new version of the T3. The T3 did not have the jetter or the lights or the camera, alright? So there's a camera here. I think there's your jetter, might be over here by the looks of it. 2 lights, okay? So camera, lights, jetter by the looks of it. Although no, I'm wrong there. The jetter is on the other side. Sorry. T4 with parallel jaws and camera and light options. The ability to have a camera view at the jaw makes minute tasks that much more precise and substantially increases the ROV's inspection abilities. Position control arms are highly dexterous and provide the fine accuracy necessary to perform complex subsea tasks. Position controlled or spatially coordinated arms means that the arm and the user inputs are spatially comparable and function in unison based upon the available range of motion of both the arm and the controller. The controller is the same shape and range of motion as the arm for intuitive operation. Okay, so some people have their forearm going on the inside of this, but I used to do what this person's doing here. Alright. So whatever you do, this is the master arm. This arm here will do, okay? So sometimes the switch ain't as big here, okay? And there's a book for this, like an instruction manual. So this can get pretty in-depth. You can set all the degrees of range of motion for this arm here, okay? Now this is important to know. A button on the end is used to freeze the arm in order for the operator to reposition in its reference to the slave arm. Collar buttons control the jaw function. Alright, so you're moving your arm around, right? And this is not, the master arm now is not in position as, because it should be in the same position as the slave arm. So you just freeze your button and then put this master in the position of the slave. Or if you want to pass this over, right, to another person, or if you're finished for the day, freeze it, and you should exit out too. Because if this drops and you just touch this off your leg, sneeze, whatever, if it hits something, you could potentially unfreeze the arm and the arm will move. So freeze and exit out. Alright? Now, forward jaw band, aft jaw. That means close, so you're just squeezing on this, and the jaws close, and you can squeeze in on this, and the jaws open. Now there's a mode called toggle. I do believe it's toggle. The forward jaw band does both. Okay? And difference with toggle is in rate. So rate is a slower movement, and toggle, these will open up even wider and faster, okay, and close. Whereas in the rate mode, they'll just, slowly open, slowly close. You can set the speed too, but on the rate it's pretty quick. All right, or on the toggle. I'm sorry, toggle. Don't want to confuse you. So with all this, you got to do it. Okay, it's easy for me. It looks like I'm having difficulties myself explaining it. But you just got to, wait till he gets on the simulators. And practice makes perfect. Provided you practice right. Okay, no sense in practicing something wrong. You'll only train yourself to do it the wrong way. Okay, so position control means that they utilize precise servo valves which have a much lower tolerance for dirt and contaminants, and they must therefore have a fully independent hydraulic pump and reservoir. Position controlled arms are also more expensive and they require a more sophisticated subsea control system. Subsea slave electronic battle for T3 arms are usually not quite as rugged or as strong as similar rate controlled arms. The spare parts are very expensive. A single joint resolver costs about $6,000, and a single C-net connector costs about $2,500. If you have to ask how much the manipulator system costs, you can't afford it. Alright, so these arms are, like several $100,000, okay? This here is like 25,000, roughly, if not 30. Alright, so the arms can go like up to $250,000. The Titan Master Controller offers a 6-degree of freedom miniature master arm that is simple and intuitive to operate. Is a number of function keys that permit the operator to view diagnostic system status information. Has advanced features that permit individual joint freeze, position scaling, ability to alter the ratio of master-slave arm movement. This is what I was talking about earlier. Other features include programmable stow, deploy pathways, individual joint movement limits, incremental gripper movement, individual joint diagnostics, wrist rate controller, and automatic error checking. So this is just like, advertisement for the Titan, right? I'm thinking it had something to do with the nuclear rods and power in the nuclear power plants. I could be wrong, but I do believe they're using robotic arms for to change out the plutonium or the uranium, whatever they're using. Okay, now see this here. You got to make your own guard, because this, sometimes people smack into this actuator, okay? You don't want that, because this is what draws it in and up, right? So PVC pipe, unbolt, slide it over, bolt it back on to the torque specs, and you got yourself a little protector, okay? Remember to do that offshore. You'll be highly praised for doing it, okay? So that's a weak link there. So the difference, I don't really show it too clearly here. T3 and T4, they almost look exactly alike, except for the T4 has the lights, the jetter, and the camera on it, okay? So here's up top, right? This is not going to be subsea, obviously. So the controller is connected to an interface box that feeds the RS-422 or 485 or 232 signal to the fiber optic multiplexer unit, where it's converted to a light signal for integration into the fiber optic telemetry string. Green is good to go, okay? You see that there? So position control arms typically require more maintenance than rate controlled arms due to the following reasons. They have an electronic component including the PCBs, servo valves and coils, and C-net connectors. They are more sensitive to rough usage, which can lead to failure to ring seals, resulting in water ingress and compensating oil leakage. They are very sensitive to water ingress, must be flushed thoroughly on a regular basis. They have separate hydraulic power and pressure compensation circuits that must be maintained separately from the ROV system. Alright, so the to flush it, you know, you put your arm up like in a same like hello position, right? Flagging someone in. Tie it up, and there's a couple of the highest hydraulic port up. You would undo or loosen it up. You'll hear a little psss come out, right? That's a bit of air if there's any air. And you just flush it, like pump oil in at the bottom until a nice flow of oil comes out at the top, right? Meaning no air or no bubbling. And once again, manipulators are one of the main reasons why the work class RVs are so effective at what they do, setting them apart from simple observation class RVs, HOVs, and AUVs. Alright, so once again, eyes and hands of the rig, alright? Eyes and hands of the boat takes the place of a person, as in a construction diver. Okay, so you got to have a manipulator, or two, I should say. Electrohydraulic RVs are extremely versatile in that they can simultaneously maneuver using powerful thrusters, do work with the manipulators, and perform almost unlimited tasks utilizing work skids fitted with a multitude of specialized tools and equipment, and do it safely with no risk to human life. As the current subsea industries evolve and new industries are created, there will be an increased demand for more specialized equipment for more difficult operations in increasingly hostile subsea environments serviced and operated by highly trained personnel. The RV industry has proven that it can adapt as required, and the future looks bright for young people willing to take up the challenges as initiated by the earlier generation dating from the 1950s and onwards. Alright, so here's craft, okay? So craft robotics. You know, I'm not going to get too much. You can just like Google robotic manipulators if you want, okay? So like craft has a few here, right? Viper, Predator, Raptor, the Grips, the Scout. Even got their own robots. The Schilling T4, Seatronics, right? But FMC, okay? Schilling Robotics or FMC. So hopefully that helps you out. Alright, so that more or less concludes the intro course for slides. I will be uploading a link each document, I guess, for several videos to watch. As usual, any questions, email me and I'll get back to you. And hopefully we'll meet face to face soon enough. Over and out.